All right, we are in the number theory portion of the option for higher level math. So we're going to be talking about different things that you can do with integers. We're going to ignore decimals, fractions, all of that for now, and just focus on integers. That's what discrete mathematics is. It's the focus of integers. So before we start, we need to talk about some terminology. If you see that hollowed out z, that is the set of integers. And I've listed most of them there for you. If you see the same hollow z with a plus, that means I only want to talk about the positive integers. If you see this kind of curved looking e, that literally means that it is an element of something, or it is a member of something, of some set of numbers. All right, and if you see that little arrow, that means that something implies something else. You've probably seen that in geometry when you were talking about if-then statements. So the hypothesis would imply the conclusion. And if you see the arrow going both ways, that means that the hypothesis implies the conclusion and the conclusion implies the hypothesis. So we call that if and only if. If you see two numbers with a vertical line between them, that vertical line means that the first number divides the second number, or the first number is a factor of the second number. So you might see 3 and then vertical line and then 6, because 3 divides 6, or 3 goes into 6, or 3 is a factor of 6. All right, and then you may have seen this before. This is the greatest common divisor. You may have heard it called greatest common factor, but it's for our textbook, it's going to be called greatest common divisor. And then similar to that, you've seen this, it's LCM. That's the least common multiple of 2 or more numbers. So that's just some terminology we need to get straight before we start. So we're going to talk today about the division algorithm. And it's a pretty straightforward algorithm. We're just going to be looking at two integers, a and b. And given those two integers, we're going to come up with a unique value of q, which stands for quotient, and a unique value of r, which stands for remainder, so that a is some multiple of b plus a remainder. All right, so let's see what that means. I think that's basically what I said. So you get a unique quotient and you get a unique remainder, and that remainder has to be somewhere between 0 and b, which is the number you were dividing by. Okay. So it could be 0 or it could be positive. So when you're doing positive a's and b's, that's kind of the same thing as converting from improper fractions to mixed fractions. But then once you get into negative values, it gets a little different. So I do want to go over at least one example of that. So let's say we're talking about 17 and 3. So if I think about it, I want to divide 17 by 3. And q is going to be the largest amount of 3's that I can take out of 17 without going into the negatives. And then r will be whatever's left over. And I can calculate that using the formula r will equal a minus bq. That's just a rearrangement of the formula I gave you before, which was a equals bq plus r. All right, so letting a equal 17, letting b equal 3. If I divide those on a calculator, I get 5.66666 repeating. So that means the largest integer I can take, or the largest number of 3's that I can take out of 17 is 5. So my q is going to be 5. And then to figure out what the remainder is, I take 17 and I subtract out those 5 3's, and I'm left with 2. So just like before, when I was talking about improper fractions and converting those to mixed numbers, 17 over 3, since I'm dealing with a is 17 and b is 3, 17 over 3, if I convert that to a mixed number, then the whole number out front is going to be 5, and then the numerator of the fraction that comes after is going to be 2. So kind of like q and r being used in a different sense. Things get a little tricky, as I said, when you start dealing with negative numbers. So I'm going to do an example of that. Let's let a equal negative 38 and b equal 13. If I divide that, I've got negative 2 point something. And remember, my definition of what q is, q has to be the largest integer that is less than negative 2.92. So that's not going to be negative 2 because negative 2 is actually higher than negative 2.92. So I've got to go down or to the left on the number line to the next integer that I would hit that's closest to negative 2.92, and that would be negative 3. So we're not actually just chopping off the decimal with negative numbers. I actually have to go down an extra one. And the reason I do that is so that my remainder remains positive. So I can stick to my definition of what the remainder is supposed to be. So Q is going to be negative 3. And then to figure out my remainder, it's going to be A minus B times Q. And I just figured out what Q is. So if I plug all of that in, I get a remainder of 1. Okay, remember that R has to be between 0 and, in this case, 13, whatever my B value is. Okay, so we can't really think about this in terms of improper fractions when we're talking about negative numbers because your Q always has to go one less than what you would think it would be. We are going to do more examples of these tomorrow, and it is going to lead up to something bigger, which is called the Euclidean algorithm, and that's going to help us do something really cool with linear equations way down the road. So if you have any questions, please let me know, and I will see you tomorrow.